Hi, my name is Eric Reichel. I'm a PhD candidate here at the University of Arizona in the College of Optical Sciences, and I'm going to be presenting our novel imaging system, which uses photoacoustic imaging to assess cutaneous skin lesions. So to begin, I'll briefly introduce our group. I'm part of the Experimental Ultrasound and Neural Imaging Lab, which is led by Dr. Russell Whitty. We have a couple other students in the lab. We have Christopher Salinas and Abhima Gupta, and we work closely with our cancer center clinicians, Clara Curiel and Delaney Stratton. And we primarily focus on imaging of the skin. In terms for cancer, we're looking at things like subcutaneous melanomas and things along those lines. So the motivation for our research was that there's an unmet need for a non-invasive and real-time imaging method to detect metastatic cancer deep below the skin surface. So traditional optical imaging systems such as confocal microscopy really are unable to have a depth penetration beyond a millimeter into tissue. And so this is something that would be particularly advantageous to have that depth information of these lesions, or other imaging modalities such as traditional pulse echo ultrasound can provide this up to a centimeter deep. Really, they don't provide anything in terms of material specificity. So we don't know exactly what we're looking at in terms of the constituents. We only have the structure of the ultrasound can provide. And this is where our solution kind of comes into play, which is using photoacoustic imaging, which is a type of ultrasound imaging, but instead of sending ultrasound into tissue and then measuring the reflected ultrasound like that's done in traditional ultrasound, instead what we can do is we can use light to generate sound. And so typically what we're doing is we send pulsed laser light into the tissue, which is absorbed, and then that generates ultrasound, and we can use that to create our images. Now, this is advantageous because now our image contrast is based off of the optical properties rather than the mechanical properties. So we can try and differentiate materials with similar mechanical properties that might have different optical properties. And so what this means for looking at skin lesions specifically is this enables us to be able to measure things like blood oxygenation. We can map vasculature and introduce exogenous contrast agents, perform spectroscopy, things along these lines, which is particularly important when you're trying to diagnose and monitor suspicious cutaneous lesions. And so photoacoustics has this really high depth penetration of greater than a centimeter. It's a real-time imaging modality, relatively inexpensive, and it can be portable. So this is a really cool method of performing ultrasound imaging with lasers, where essentially we're integrating an optical source to a traditional ultrasound system, and we can perform both the pulse echo imaging as well as the photoacoustic imaging. And so what our research kind of looks like and what my dissertation is focused on is creating these custom pulse echo and photoacoustic imaging systems where we're trying to image over an entire volume to look at a lesion. So in these images here, we can see our new system is essentially attached to or attached around a lesion that we're trying to image, where it scans across the entire volume. And now we have all this information of both structure and material specificity over an entire volume. And so where we are in our current research right now is that we are just finishing up with our first in vivo trials, where we imaged a couple of patients to act as our baseline, where we looked at just common benign moles essentially, and we're using these as a baseline. And we are currently in the process of going from our benchtop system to a mobile system, where we will take this cart-based system to the clinic, the dermatology clinic where Clara and Delaney work at. And we'll be using this system for initial clinical trials to study and ideally monitor melanomas and whatnot. So again, my name is Eric Reichel, and if you have any questions, feel free to reach out to me at my email below. Thank you.